Hi, welcome to StatStuff. I'm Matt Hansen. This lesson is part of an extended series of lessons covering the topic of building the measurement system analysis, or MSA, which is used to validate the reliability of our data. Specifically, this lesson reviews the Attribute ARR test used in MSA for analyzing discrete data. So please be sure to check out the prior lessons in this series about leading an MSA. But for now, let's review again the 4 general steps for building an MSA. The 4 general steps we're going to use for building the MSA begin with planning the MSA. That usually involves determining what needs to be measured, what MSA tools are going to be used during the MSA, and who's going to be part of the study itself, what samples or masters are we going to use for testing the accuracy, and how are we going to conduct the actual study itself. The next step is to actually conduct the MSA. That's going to involve scheduling the study, leading the study itself, and actually running it, and then collecting the data from the study. Once we've done that, then we can begin the third step of analyzing the results from that study. That's going to involve compiling all the data that was collected during the study, processing the data using the MSA tools that we plan to use ahead of time, and interpreting the results and doing the analysis on that data during the MSA. And then finally, after we've done that, we want to improve the measurement system. That's going to involve determining if we need to make improvements to the measurement system itself. If it does, then we need to find out what are those improvements and changes we need to make to the measurement system. And if we're making changes to the measurement system because we didn't trust reliability before and it failed the MSA, then that means we might have to redo the MSA. And when we redo it, that's a way for us to assess whether the corrections and changes we made to the measurement system were effective enough to the point where now we can trust the results coming out of the measurement system. Now let's dive into that third step and talk in more detail about how we will analyze the results collected in an MSA. Well, for the third step of analyzing the results of the MSA, we want to begin with compiling all the data that we've collected during the MSA. So as each trial of data is returned by each of the operators that are involved, we want to be sure that we're clearly defining and storing that data before we do any compiling at first. That way we know which operator had provided which set of data. And once all the data is collected from each of those different operators, from every one of the trials that you're running, then you want to begin to compile the data if possible. And the method for compiling the data really depends on the MSA tool that you're going to be using. And that MSA tool really depends, again, on the type of data that we've discussed before. So processing the data is the next big step, and that's where we're going to be determining which MSA tool we're going to use and how we're going to interpret the analysis results. So again, there are 2 basic types of MSA tools that we'll review, and it's going to depend on the type of data that you have. If you're using discrete data that you're analyzing, you want to use the Attribute ARR. ARR stands for accuracy, repeatability, and reproducibility. Or if it's continuous data, you want to use the gauge R&R. Again, that's just going to be looking for a variation within continuous data from a repeatability and reproducibility perspective. So what we're going to go over next is the Attribute ARR tool and how we're going to interpret those results. Now let's talk about how to set up an Attribute ARR test in Minitab when you have just a single attribute. Well, when you have a single attribute that you're reviewing for an MSA, then you want to use a single attribute ARR study, or what Minitab calls the attribute agreement analysis. So this particular tool does a simple analysis on a single set of discrete values. Again, discrete values being like yes, no, good, bad, on, off, true, false, or some sort of attribute type of data. Now the example that you can use for this one is one that we provided on the website, and also this tool is not available in the student version of Minitab. Unfortunately, this is one that is required, that's only available as part of the full version of Minitab. So if you only have the student version, unfortunately you're not going to be able to do it in this particular method I'm about to show you. However, continue watching because we have another method you can use for doing this type of Attribute ARR test. So for this example, you'd set up in your data similar to this example that's here within Minitab itself. First, you have a reference for each item that's being reviewed, what we've called part number here. And then next you want to have a set of data or a column representing the master, or your correct answer, what you're expecting your answer to be. And then next you also have the actual answer that's given by each operator, the actual result that they gave you, because that's what's being compared in these to the master itself. And then you also have to have a column that represents the reference for each operator, who the operator is that gave that particular answer that you're comparing to the master. And then finally, what we have in this example is a reference for each trial run. For example, if it was the first trial that was sent to them, or second or third or fourth review trial. Now Minitab in this particular study does not require that particular column, but that's okay. In this example, it was a way for us to at least reference it before compiling the data so we know, was this an answer that was provided by this operator during the first trial number, or maybe second or third or so on. Now when you want to go into Minitab to actually run this, you go to Stat, Quality Tools, then you select the Attribute Agreement Analysis, and then it displays a dialog box like this. And when you have these columns that are given in this example dataset that's on here, like in the dataset that's provided on the website itself, these are where you select the attribute column would be the answer column, the answer that's given by the operator. The samples themselves are referring to the part number or whatever item number you might have used to reference each thing that's being compared as a unique value. And appraisers are those operators, the reference for the different operators that were used for the study. Now if you have the known standard that it's comparing to, that's what you can identify here as well in this part of it. And you click OK, and then next what we're going to look at is the actual output that's run from Minitab. Alright, now let's talk about how to interpret the results when you run that test in Minitab. Now if you run this test in Minitab, it's going to output for you 4 different types of results. The first result is going to be a section that's called Within Appraisers. That's referring to the repeatability perspective that we've talked about. It's also going to have a section called Each Appraiser versus a Standard. That's the accuracy perspective that's for each of those operators. Then it's going to have a section for Between Appraisers. That's the reproducibility perspective we've talked about. And then it's going to have an output section that says All Appraisers versus a Standard. This is again the accuracy perspective for all operators rather than for each operator. Now when you're looking at each of those different outputs for those 4 different results coming from Minitab, what you want to pay closest attention to in the results are looking at the percent and the kappa, and you're going to use it based off of this type of scale that's listed here. So you're looking for something that is greater than 90%, you know it's good. If it's less than 70%, chances are it's bad and it fails the MSA. But it's somewhere in between 70 and 90%, maybe it is okay after all. Or you just have to make that judgment call to assess whether that's enough risk for you in accepting the reliability or not of the data. So as an example of the output that comes from Minitab, here's the section that begins with the Within Appraisers. So it's going to be a long list that's output from Minitab. And in this first section, again, what you want to look for is the percent that's listed here, and based off of the scale that's listed, since these are, the first one is at least 90% and the next one is at least 90%, then we know for this first 2 appraisers or operators that we had that it's acceptable. The third one, it's really close, but it's on the high end and just barely missing our absolute acceptance. So we might consider that to be okay, and again, depending on the amount of risk that we're willing to accept on that. But we also want to look for kappa. Now I'm not going to get into the explanation of how they calculate kappa, but just trust me in saying that there's a mathematical formula that's used for calculating this, and the intent behind calculating this kappa is to make sure that the result that was provided by the operator is not just per chance that they happen to select the right answer. In other words, if the right answer was, if we're comparing something that's true or false in the answers, and the answer we expected is true, and the operator actually selected true, well, they had a 50-50 chance of actually selecting true after all. So did they select true because that's what they intended, or did they select true because they knew that was the right answer and they just happened to select the right answer after all? Well, that's what we want to assess here. And the kappa is that mathematical formula that's a more conservative representation and to evaluate, did they just happen to select the right answer, but maybe they really didn't intend it after all. So it's generally going to be a number that's less than the percentages of what was showing up above. So in looking at these, again, you want to look at the same scale. In this example, they all fall within at least 70% and less than 90% also. And again, that's going to be within our barely tolerable range. And we have to just make that determination. Is that going to be acceptable to us or not? If it's not, then chances are we might have to go back and rerun the MSA, or at least recalibrate, move on to that 4th step of improving the measurement system. But maybe it is acceptable to us. Maybe 70% is considered good, and that's where we have to make that judgment call. But at least now we have a number affixed to the process and how we've evaluated the measurement system to know whether we can really trust the results or not. And this is where we have to make that judgment call to know whether we should trust it or whether we need to make any corrections to the measurement system. Now let's talk about how to set up an Attribute ARR test in Excel when you have several attributes to analyze. Well, as I mentioned before, the single attribute ARR test that we looked at in Minitab is only available in the full version of Minitab and not in the student version. Also, as a result of being in Minitab, it might be a little difficult for those who don't have any version of Minitab available. So what I want to show next is the multiple attribute ARR, and this is an analysis that's actually just done within Excel, where we do a similar approach in analyzing the data, but it's all within an Excel tool that I'll share with you, and it's available also on the website. So this tool also looks at discrete analysis on many set of values. It's not just a single one, but it could be multiple values that you're looking at. And it can be continuous values as well. So I find this tool to be actually very handy when I'm doing an MSA. Now, a blank template, again, is something that's available on the website if you want to pull this down and run this for your own type of study. The template that I have available on the website is when you have 40 different parts that you're evaluating, and you have 20 different attributes or 20 different maybe sets of data that you're analyzing for each of those parts, and it supports up to 3 different trials that are being run. So it's very versatile and allowing you to work with multiple parts, multiple attributes, and also the multiple, or at least up to 3 different trials that are run. So what I'm going to show you next is an example. If you have this data out there, you can run this, and it's not just the template itself, but it's the example of the data that you might run, and it's basically using 4 different unique values. So in this example here, this is what it looks like when it's in Excel itself. The first section that's up here is for setting the standard or master values. So in this particular tab where it says enter the data for the standard here, that's referring to that master or whatever you're using that everything is being compared to. This is the accurate results that you're looking for. And then over here where it says in the column part number, that's referring to the actual number of parts of the things that are being compared. Again, we've said before how you want to have at least 10 or 20 different examples, but you could easily have at least 30 or 40. And this actual example in this template allows you to have up to 40. And then this next section over here, going across the top, this is where it allows you to have at least 20 different attributes or 20 different measurements that you want to compare. This example only has 4 that we're showing, but again, it's not just a single one like what we had in Minitab. You can have up to 20 listed across here that this will do the full analysis on. So this is where you would begin with setting up your data, again, setting up in here the different parts and setting up your standard or master that you're comparing everything to. Alright, now let's talk about how to interpret the results when you run that test in Excel. Let's walk through the steps again for when you want to run this type of test within Excel. You want to again type the data in the data entry tables. The data should align to the right operator or trial in the data entry tables tab of that Excel sheet. Now first, again, you're going to enter in the standard or the master values like we had just shown in the previous slide. This is only entered at one time, and it doesn't have any multiple trials in it, but it just has one standard set that's defined up front. And next after that, you're going to enter in the data for each operator and each trial. So it's going to go in the order of operator 1 and their first trial of data, then operator 1 and the second trial of data that they have, and operator 1 and their third trial, and then so on. Again, it's allowing for up to 3 different trials, again, for the multiple operators. And you just continue that process where it moves on next to the operator 2 and their trial 1, operator 2 and their trial 2, and so on for all the different operators that are involved. And if you neither have 40 parts or you don't have 20 different attributes for each of those operators or trials, then just leave those cells blank. You skip them. For example, if you only have 2 trials that are run across 3 operators, then you'll fill in the section for operator 1 trial 1 and operator 1 trial 2, and then you'll leave the operator 1 trial 3 blank, and you'll skip that section and move on to operator 2 trial 1, operator 2 trial 2, and so on. So it's okay to leave the sections blank if you don't have any data to input for either the parts, for the attributes, or even if you're missing some trials. It's there and available for you if you need it, but it does not have to be filled in. The important thing is that you at least have all the number of parts and the attributes at least consistent with the same order and layered the way that you have in the standard or that master section of that same tab. So once you have all the data input, then you go to the Report tab, and you're going to click on the button that says Run ARR Report. And then when you click on that button, it's going to create an output that looks a little bit similar to this. And this is the button that you would press to execute this. And once you click there, again, this is going to be taking all the data that's on the data entry table, and it's going to calculate all the results that are listed here in this one page for the MSA results. So this section that's listed over here is where it's breaking it out by accuracy, repeatability, and then reproducibility. And then this first section over here is what breaks down between whether you're looking at the total, that is accounting for all the different things that you're analyzing. If you have multiple measurements that you're using, it's accounting for all of those at once, and it's also breaking it down per metric that you're analyzing. Now what you may find is in each of the results here, it shows you where the MSA passed or failed. And it's using the scale of 90% or greater as pass, less than 90% is a failure. And it'll turn green or red depending on whether it's above 90% or below 90%. Again, you might want to use your own different scale or threshold for determining pass-fail, but at least it gives you that result, and it's using the default of the 90%, at least as a starting point. But you may find, though, you might see for one particular metric that you're using, it could easily pass the MSA. The operators might have gotten that information absolutely perfect. But on the overall scale, though, when you're assessing for all these different metrics at once, you might see that they failed. Again, this is where you have to do a judgment call, where you might see that from an accuracy perspective, they're not too far off in reaching that 90% threshold if that's the default you're using. But for repeatability, they weren't as consistent within themselves in following the right process and getting the results. From a reproducibility standpoint, we failed even more. They were not as consistent between the different operators when we're comparing them. This is the kind of thing that you're looking for. You're trying to see where's the greatest opportunity from this, and this is going to help us know if we need to move on to make improvements to the measurement system and where we need to make improvements. So in the example that we're seeing here, we're seeing the greatest success from the accuracy perspective. Even though these aren't really perfect and they're not above 90%, they're far better than this reproducibility. So what we're seeing is there's inconsistency between the operators in these results. If that's the case, then we might want to make certain changes that helps reduce that variation between the different operators. Maybe that's making sure they have a consistent process that's defined for each of them, a certain SOP or something like that. But again, this at least gives us a guide to figure out where we might need to make some improvements, because we might see the greatest risk or failure in one of these perspectives of accuracy, repeatability, or reproducibility. All right, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way. There are a couple things I'd like you to try to do. First of all, let's start with the Minitab file. Open up the example that's provided on the website and try to run the attribute agreement analysis within Minitab as we went over within this particular lesson. And as you do your results look the same as the examples that I've shown in this lesson? And then try to randomly select within the data at least 10 different values that are in the answer column and change the value. So if it's good, change it to bad, or if it was showing bad, change it to good. Just randomly select a few of those and then try to rerun that analysis and then compare the results to see how those changes that you made affected the results and how does it differ. Another thing that I want you to try is to actually use that Excel template using, again, the file that's provided on the website. And go to the Data Entries tab, the Data Entry Tables tab that is, and try to randomly select 20 different values in there. It could be for any operator or any trial, and try to make some changes to some of the data. Go in any order that you want, where you want to be able to see the changes. And then go to the Report tab and click on the Run ARR Report button and try to rerun that analysis. And when you do, look at the results and again see how those results differ. We already saw in the example that was provided here that the results were showing that they were failing at an overall standpoint. Well, maybe you want to try to duplicate some of the values that you have in the standard section so you can see if you can get a more accurate rate, and see again, play with it to see how those results compare when you make these different changes, and so you can see how you can interpret the results in these different types of analyses. Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.